Very good afternoon. Hello student. Today I came over here to discuss NEET 2025 chemistry question paper solutions. So welcome back to my channel Kunal sir at JEE NEET Chemistry World. So this year question paper is not like last couple of years, because last couple of years question paper came because of the corona effect. But this year question paper is little bit, some questions, not all, some questions they put it little tricky way and it is true. And whoever studied, but still if you studies the concept proper way, like my channel, like that type of discussions will be there in the every chapters. So if you are very thorough enough, if you study with well enough concept from very proper way, then you can solve this year question paper, all questions. But as far as my knowledge is concerned, there are one questions there will be ambiguity, that means two answer is possible, as well as there are 4 to 5 questions the tricky way they ask, and you need have a very depth concept about the subject, then only you can able to solve the questions. It's not like come last couple of years. And this year physics questions also was tough, everybody knows. Even biology, zoology also 1 or 2 questions there are ambiguity is there. So overall effect in exam hall department with that to get all questions is really difficult for the student. But anyhow, whoever studies properly, proper way and practice proper way, for them possible to solve the questions. Now let us start discussion of, I choose few model top questions, easy questions everybody will get, that is now issue. Some model top questions from this year NEET 2025 question paper I choose, and I am going to discuss that in detail, not only just taking the key. Now in these questions they are giving this compound, you look at, this is nothing but a Ester, PHCOOCH3. In that Ester, how can we convert it to aldehyde? Even I can say your first point, even NTA, these questions they have to give one data they missed, I can guarantee you, because question has to be asked in a proper way. First of all, you look at, if you have a ester like RCOO R dash. Now I am telling R is a alkyl group, R and R dash are not equal or maybe equal. I am taking it is not equal. Now here if you are giving DIBAL, everybody knows what is the full form of DIBAL? Diisobutyl aluminum hydride. Diisobutyl aluminum hydride. If you give the DIBAL, then DIBAL has to be given minus 78 degrees centigrade, my dear student. Then only this part will be your ester, it will be converted to ester, this part will be converted to aldehyde, and this part of ester will be converted to alcohol. So this will be the scenario. But DIBAL has to be given in minus 70 degrees centigrade, then only, because this DIBAL is diisobutyl aluminum hydride. That means the structure is isobutyl. You look at, here they are giving isobutyl, diisobutyl, isobutyl group means this is the isopropyl group, this is your isobutyl group. So now diisobutyl, that means 2 times of this one, diisobutyl aluminum hydride, this is called as a DIBAL. This DIBAL specialty is nothing but a, that will, cyanide is there. If you have a cyanide, RCN, DIBAL giving means it will be converted to corresponding aldehyde. Even Stephen reaction also used to do same thing. Even DIBAL, this is the structure, diisobutyl aluminum hydride. DIBAL has to give in minus 78 degrees centigrade, then only this part will be converted to aldehyde and this part will be converted to alcohols. Now the question is, you look at the questions very carefully. Now, but in ester, if you give the DIBAL in 25 degrees centigrade, my dear student, then this part also will be alcohol and this part will be also alcohol. Then here product is RCH2H plus R dash OH, this is the product, 25 degrees centigrade. But NTA not provided that one, the temperature. This should have to provide, because organic reaction, there are a lot of conditions, reagent, they will behave in a different manner if the condition of reaction condition are changed. That's why that things is missing over there. They have to give minus 78 degrees centigrade, then only DIBAL will form the, this part I told you, RC double bond O. That means if you look at carefully, this part will be converted to your corresponding aldehyde, which is nothing but a benzaldehyde. With that, this part will be your alcohol. With that, their product will be CH3OH. Then only that question is validated. If you give sodium borohydride can't reduce the ester. H2PD barium sulfate, that means it is a Lindlar catalyst. Lindlar catalyst react on triple bond to double bond as well as acid chloride. And now lithium aluminum hydride reduces ester to the what? Ester to the corresponding alcohol, because here this part will be CH2H and this also will be corresponding alcohol. Only if you look at that your DIBAL, diisobutyl aluminum hydride, only this is the DIBAL, this is your DIBAL. So DIBAL at minus 78 degrees centigrade, if you have ester, RCOOR dash, RCO part will be converted to aldehyde. That means this part converted to aldehyde and this part will be converted to alcohol. Your condition has to be mentioned minus 78 degrees centigrade, because based on the temperature, product will be different. So now, as they are giving its aldehyde formation, by default I have to understood the temperature is maintaining minus 78 degrees centigrade, but this is the conditions. So then only the DIBAL used to form the corresponding ester to aldehyde. That's why which options will be your answer? Fourth options will be your answers. Now look at the next, another question based on acidic strength. Now generally if you look at stability of the conjugate base is more, stronger will be corresponding acid. Now if you look at all those cases like HCOOH, formic acid, on dissociation it will give HCO O minus and H plus. After giving the H plus, species is called as a conjugate base. All cases conjugate base will have a equivalent resonance structure. But the question is, all conjugate base, here CH3 will provide the plus I. Here more plus I will be there. Here the effect of plus I is more. But conjugate base stability will be what? Less. Even though if you know the pK value, generally when the faculty used to teach, they used to mention the pK value. Why? Because generally aromatic carboxylic acid are stronger acid than the aliphatic carboxylic acid. But one exception is there, formic acid is stronger than aromatic carboxylic acid. The pK value for formic acid 3.7, acetic acid pK value is 4.7. This is around 3.2 or 3.7 in that range. pK value of acetic acid is 4.7. Now, lower is the pK, higher is the acidity. Even though, if you look at here, conjugate base is not destabilized by any electron releasing effect. But whenever, if you look at the acetic acid, this will be CH3, CO, O minus plus H plus. This CH3 will give you plus I effect. That's why conjugate base will be what? Destabilized. As the stability of the conjugate base is less, then the corresponding acid will not be stronger, it will be weak acid. So that's why if this stability, conjugate base stability is not there, reaction will not go forward direction. If reaction is not going forward direction, it will not give the H plus. So that's why even though pK value also will confirm the data, formic acid pK is 3.2, acetic acid is 4.7. Lower is the pK, higher is the acidity. And you look at this structure here, both the CH3, like that situation you will come, both the CH3, here CH, here you have a CH, here you have a CH, and here you have a C double bond O and O minus. This conjugate base, this will give plus I. This conjugate base will be more unstable, and this one will be most unstable conjugate base. So that's why reaction will not go forward direction, not give H plus, acidity will be less. That's why which options will be your answer? First options will be your answer. Now look at the next slide. If you look at the next slide, here they are question giving already. It is a very book questions. That means Lassaigne test, that means special element test of organic halogen, nitrogen, sulfur, and all those things. If you have a special element in organic compound, they used to fuse to it a solid sodium. Then sodium X is halogen, means NaX. Sodium with carbon, organic compound carbon, nitrogen, NaCN. Further, we have to test with this. We know after that NaOH, H2SO4 add, ultimately Prussian blue color used to come. From there, we used to qualitatively analyze that nitrogen is present. And here sulfur, Na2S, lead acetate solution, means PBS, black precipitate will come. Only the second option, that is not related to this option, is not related to Lassaigne test. This one related to Lassaigne, but option 2 is not related to Lassaigne. Now, if the rate constant of a reaction is 0.03 second inverse, from the rate constant we understood this is a first order reaction. In a first order reaction, rate constant will be time inverse. So that's why it's a second inverse. From there we understood it's a first order kinetics. How much time does it take for the 7.2 mole per liter concentration of reactant to get reduced to 0.9 moles per liter? Directly you will apply that formula and you will get it. What formula? They are telling how much time. T equals to 2.303 by K. K is a rate constant. Log of C0 by Ct, or A by A minus X. C0 is the initial concentration of reactant. Ct is the final concentration of reactant. So then this K will be equals to, they are giving in second inverse, this K value 0.03 second inverse, and then C0 is the telling 7.2 and Ct is 0.9. Now after that decimal point you will cancel out, then you will get 9, 8 you will convert 2 to the power cube, and then this log 2 will come, 3 will come this side. Your calculation will be T will be equals to 2.303, here 0.03 log of 2 to the power cube. This power will come over here, log 2 value they provided. If you calculate, you will end it off your answer, which will come to the third options. Now 50th questions here, they are giving one questions this here. A hypothetical diatomic molecule with a bond order 0 is quite stable. But bond order 0 means, what is bond order, my dear student? The number of bonds present between the two atoms is called as a bond order. Bond order 0 means there is no existence of a molecule. So then statement 1, directly it will be false. Statement 2, at bond order increases, bond length increases. If bond order increases, what will happen? Bond order increases means number of bonds between the two atoms will increases, bond strength will increases, bond dissociation energy will be increases, force of attraction increases, they will be close to each other, bond length will be what? Decreases. Bond order is directly proportional to bond dissociation energy, inversely proportional to what? Bond length. So that's why if bond order increases, bond length has to be decreases, because force of attraction will be more, the number of bonds will be more, they will be close to each other, bond length will be what? Less. So that's why both the statement are false. Statement 2 is also false. Statement 1 is also false statement. Is it clear? Let us look at the next slide. Here they are giving out of the complex compound, which compound will have a minimum conductance in solution. That means this question is based on the complex which will give the minimum number of ion that has a minimum conductance. More number of ion means more carrying of charge, more conductance. So that's why here you look at, here you will get how many total ion? One complex ion you will get, like this situation. One complex ion will get plus 3Cl minus, because ammonia is a neutral ligand and chlorine is satisfying. You look at chlorine here, 6 ammonia is satisfying the secondary valency of cobalt, whereas from the outside of a coordination sphere, 3 chlorine is satisfying the primary valency of the cobalt. I hope everybody knows the Warner's coordination theory, basic idea. Based on that, this one. Now if you look at over here itself, now the idea is here, if you look at here, total number of ion is 3 plus 1, 4. Here, if it is, I think here inside there will be 2 Cl2 will be there. Here there will be, I think 1 Cl2 will be there. I think this typing mistake is there in this complex. Anyhow, if it is the scenario, there will be 2 ion for this, one complex ion and outside one chloride ion. But here and here there is only one complex substance, and here also complex substance. Here cobalt is in +3 oxidation state, here cobalt is in +2 oxidation state, because both cases chloride ion is satisfying the primary valency as well as secondary valency of the cobalt of the complex. Now this complex, this is also neutral complex, this is also neutral complex. Why? Because overall charge of the complex is 0, here overall charge of the complex is 0. Now both cases, as you think, there is only one entity, and here also one entity. They are telling out of the following complex compound, which compound will have a minimum conductance in solution. As both are only single entity, both are overall carrying charge is 0, both are, that's why both the option can possible for the answer, third or fourth, both possibilities there for the answers. This is the ambiguous questions for these years. Now next questions, which of the following aqueous solution will exhibit highest boiling point? Then basic idea you look at, delta TB will be equals to Kb into molality into I. Molality is directly proportional. Kb is a constant. Molarity means number of moles. Then number of moles theoretical into I will be equals to N observed. Delta TB is directly proportional to N observed. Delta TB means TB minus TB naught. TB minus TB naught. If N observed is more, then obviously delta TB more. Delta TB more means this value is a fixed value, then TB will be more. So that is the idea based on that questions. If you look at 0.01 molar Na2SO4, the number of ion produced from one molecule is nothing but a I, because I will be equals to 1 plus N minus 1 into alpha, where N is a number of ion produced from one molecule, and now if you put 100 degree of dissociation is 100, alpha will be equals to 1. In that conditions, your I will be equals to what? Number of ion produced from one molecule. So then here there will be 3 ion. Then N observed will be equals to 0.1 into 3. 0.1 into 3 will be over here itself. That means you will get 0.03. But here glucose is a non-electrolyte, I will be equals to 1. Then here observed will be equals to 0.015 into 1. Now here urea also non-electrolyte, 0.01 into 1, I equals to 1. Here there are 3 ion will be there, but this is a 0.01 into 2 ion, potassium ion, nitrate ion. So that's why here what will be the situation? Here the situation, if you look at 0.01 into 2 ion into 2. So then here you will get 0.02. Now here you are getting 0.01 into 3, which is nothing but a 0.03. Where the your N observed is coming more in the first option. If N observed is more, your delta TB more. Delta TB more means TB more. That's why we'll exhibit maximum or highest boiling point. Which option will be the answer? First options will be the answers. Now look at the next one, please. Here what they are asking, if you look at, like nitrogen can ammonia form arsenic, can form arsine. Yes, arsine means AsH3, that is formation is possible. But statement 2, antimony cannot form antimony pentoxide. In the light of above statement, choose the most appropriate answer of the options given below. Antimony is used to form antimony pentoxide, but the question is maximum time it will be exist, always it will be exist in a hydrated form. Anhydrous antimony pentoxide will not exist. That's why that perspective, this question clarity also little missing, that antimony pentoxide anhydrous form will never exist. It will always exist in a hydrated form, water of crystallization, and AsH3 will exist. That's why statement 1 will be correct, but statement 2 will be incorrect. Now these things I hope everybody can match it up. Haber's process means iron catalyst. Walker process means PDCl2. Wilkinson catalyst means this one. Ziegler-Natta TiCl4. So that means immediately you understood A will be 1, B will be 2, C will be 3, and D will be 4. That is no issue. Now if you look at over here itself, next questions. In these questions what they are asking, ferromagnetism is considered as the extreme form of paramagnetic. Ferromagnetic, yes, definitely. Why? Paramagnetic means unpaired electron. They will be influenced by external magnetic field and they will start orienting them among the external magnetic field. But ferromagnetic means like a nickel, chromium, nickel oxide, iron. They are ferromagnetic substance. When you will apply the external magnetic field, their alignment also will be there. The tiny magnet inside, they also will be aligned along the external magnetic field, and that's why the ferromagnetic also is actually influenced by the external magnetic field. They have a proper orientation. Paramagnetic substance, due to unpaired electron, they will also influenced by the external magnetic field. That's why both are similar in nature, but we can say ferromagnetic is a very strong property. So that's why ferromagnetism is a extreme form of paramagnetic substance. Now the number of unpaired electron in chromium plus 2. Chromium plus 2 configuration, if you draw, chromium in neutral condition, atomic number 24, argon code 3d5, 4s1. Then plus 2 means, chromium plus 2 means what will be the configuration? Argon code from 4s 1 electron will be gone, from 3d 1 electron will be gone, 3d4, 4s0. Then 3d4 means how many unpaired electron? You know very well, as per Hund's rule of maximum multiplicity and Pauli exclusion principle, first 1 1 1 with a similar spin, then only paired up will be taking place. So that's why this is a 3d4. There are 4 unpaired electron is there. Then neodymium, they are telling plus 3 state. They are telling atomic number is 60. Then normal neutral neodymium, how you will write down that before the inert gas is xenon. Xenon is 54. Xenon code, that means 54 electron gun. Xenon configuration 5s2, 5p6. Then obviously here will be 6s, 6p. Whenever 6s, 6p will be there, 4a, 5d. Now if you look at 60 electron, I need to fill it up. Then 54 to 60, 6 electron is extra. Then 2 electron will be there. Over here still in my hand, 4 electron. Then 4f4, this will be the situation. How I pull that n plus L rule we valued. So then n before the orbital, what number is there? N is a principal quantum number, L azimuthal quantum number. For f orbital 3, d orbital 2, p orbital 1, s orbital 0. Then as per the n plus L rule, if n plus L value is lower, that orbital will fill up fast, energy will be lower, and which n plus L value will be more, that orbital has a more energy, that will fill it up less. So now, and after 54, 6s has a n plus L value less, 2 electron gone. Next 4f, because this is also 7, this is also 7, this is also 7 for n plus L value. When n plus L value will same, lower n value will fill it up first. That's why 4f4, 6s2. But plus 3 means 1 electron will go from 2 electron will go from here, 1 electron from over here. Then Nd plus 3 electronic configuration, xenon code 4f3, 5d0, 6s0, 6p0. That means f orbital there are 3 electron, you know very well. 3 electron means what will be the situations? What will be the situation? 1, 2, 3. There are 3 unpaired electron will be there. But in statement what they are telling, the number of unpaired electron in a chromium plus 2 is the same as that of Nd plus 3. That is not same. One is 4, one is 3. And now you look at ferromagnetism, I explained. That's why statement 1 is correct, statement 2 is wrong. Then if you look at which option is giving that answer, statement 1 is true, but statement 2 is false. First option is there. Then which options will be your answer? The first options will be your answers. Now look at the next slide. In this next slide, very nice questions, this one, organic. Now you know very well, red hot iron tube, insert information. 3 moles if you utilize, like that situations will occur now, my dear. C double bond CH. You look at the situation here also. C double bond C, here H, here H. Now here also C double bond C, H, H. Now you look at this is going over here and this is going over here. Then what you are getting? Alternate positions, there is a double bond, you are getting a benzene structure. Yes or no? You are getting a benzene structure. Like that situation is coming. Like means here double bond, then single bond. You are getting like this. Here double bond, then single bond. Then double bond, then single bond, and then you are getting double bond, here single bond, and then if you look at 1, 2, 3, 4, and here also carbon will be there. Now if you look at over here, single bond, and here double bond. Now you look at, you are getting with this and all have a hydrogen, hydrogen, hydrogen. You are getting a benzene structures. Now here diazonium salt, very unstable, little bit if you heat it up. You will get a phenyl carbocation. This will be attacked by water and then ultimately proton loss. Here you will get a phenol. So that means here you are getting a benzene. Here you are getting a phenol. So here this should be pseudo-alloy Na plus. So then soda lime heat decarboxylation. Here you will get a benzene. Now here you know alkane chapter. Whenever NXN will heat it up, molybdenum, chromium, molybdenum oxide, 7 high pressure, high temperature. There cyclization and benzene formation. Heptane means toluene. So here also benzene, here also benzene, here also benzene. But the question asking which of the following reaction does not give benzene, then which options will be your answer? Second options. So if you look at this will be the scenario. Now next, if you look at next slide. Next slide they are telling like that. Next slide what they are telling? This is nothing but a 2-methyl butane. 2-methyl butane on monochlorination. Very standard questions. This is a mains level. This type of question are very standard question. So then monochlorinations, how much will form? First you will write down structurally what are the possible position chlorine can come. This position chlorine can come. This position chlorine can come. This position chlorine can come. These two are equivalent position. Generally monohalogenation reaction used to prove it. How many your not equivalent carbon hydrogen bond is their structure, that will be determined by the monochlorination or monohalogenation. Equivalent position means same product will obtain. That's why these and these are equivalent carbon hydrogen bond. So now after that, if you look at, whenever you are giving one by one, structure is like this. Suppose here I am giving chlorine, then for this there is a no stereoisomer, counting is 1. Now whenever I am giving next place chlorine, here chiral center is there. For that plus and minus 2. That means R as well as S. Now next possibility I show you here. Whenever you are giving over here, you look at, there are no other place chiral center because these two methyl group are same. Next possibility over here. Now you look at, here you have a CH2Cl, here CH3, here carbon and hydrogen is there, and you have like that situation. That means whenever chlorine is substituting one of the hydrogen, then here chiral center is forming. So then this chiral center is nothing but your counting will be how much? For these two. Then total how many you are getting? You look at, here 1, here 1, here 2, here 2. 6. Second option is there 6. That will be your answer. Is it clear? Then look at the next questions. If you look at, this question is based on the activation energy for exothermic reaction. You know that idea I am telling. If it is your potential energy versus progress of the reaction or reaction coordinate. Reaction progress or reaction coordinate. Now, if you look at, this is your reactant, this is your potential energy level, this is your potential energy level of reactant, this is your potential energy level of product. They will go to like this, activation energy overcome. Now this is the diagram for activation energy for forward direction. This is the level, the activation energy for backward direction, and this to this level is called as a delta H of the reaction. They are asking the picture, they are asking the delta H. The potential energy level for exothermic reaction delta H will be equals to potential energy of the product minus potential energy of the reactant. So that means potential energy of the product, you look at, this is the concept, this part only use delta H. So then product potential energy is less, reactant potential energy will be more. That's why this value will come to the negative. That's why this option you have to opt. Now come for these things. This is purely based on the Born-Haber cycle. That means delta H of formation of barium sulfate solid will be equals to, all data you have to add it. The standard enthalpy heat of formation of barium they are giving, standard heat of formation of sulfide ion they are giving, then heat of crystallization means lattice energy, that factor also they are giving, and standard heat of formation of barium sulfate they are giving. So that means this minus 349 will be equals to your the delta H of formation of barium plus delta H of formation of sulfate, delta H of formation of sulfate, delta H of formation of sulfate, as well as lattice energy, that means heat of crystallization plus heat of crystallization. Heat of crystallization, if you add up, you have to get this value. This value they provided, how much? Minus 216. This value provided minus 4.15. Naturally, this value has to be 128.5. So then which options will be your answer? Third options. Next, if you look at the next slide. If you look at the next slide, my dear student, you will get to know that idea very clearly. You look at, here they are asking, a sugar is found in honey, is keto sugar, as well as exist in alpha beta anomeric form. It's a levorotatory. D-fructose is a levorotatory sugar because optical rotation will give a minus sign. That's why your inversion of cane sugar, whenever you take a cane sugar sucrose, inversion of cane sugar we used to attain. You will go plus to the overall value will come minus 90. That value will come into the picture. So that's why you need to understood these things clearly. Now, if you look at very clearly, here the structures of fructose. Fructose structure, if you look at, my dear students, structure is like this: CH2OH, after that C double bond O, after that OH, H, after that HOH, HOH and CH2OH. This is the fructose. Now, if you look at this OH, this will attack over here and this is open up. They will go to the cyclic form, which is pyranose form of your fructose. And now, whenever this will open up, OH can go to the right side, OH can go to the left side. It's a planar structures. Both front and back attack possible. Based on that, the different arrangement of OH is possible. So that's why that is will form the anomeric form and alpha beta. That is only they are telling. And now, levorotatory means it is showing the optical rotation negative, D-fructose optical rotation negative, and honey used to present this one, and it is a keto sugar. You look at keto group is there. That's why which options will be your answer? Options 4 will be your answer. Next one, if you look at in this reaction, this is a fantastic question they asked this year. Now, for the reactions, A gas is converting to 2B gas. If you look at these things very carefully, I am explaining these things. A gas is converted to 2B gas. The backward reaction rate constant is higher than the forward reaction rate constant by a factor of 2500. That means backward reaction rate constant is higher than the forward direction. That means Kb will be equals to 25,000 into Kf. That is only they are telling. Now, backward reaction rate constant is higher than the forward direction rate constant by a factor of 2500. Kb is a backward direction rate constant. Kf is a forward direction rate constant. What do we know, my dear? K equilibrium constant in terms of a concentration, I am telling Kc. Kc will be equals to K by Kb. That means lot of places explanation is there. This clarity is missing. K by Kb equals to equilibrium constant, but that will give you Kc, not the Kp, my dear. Because whenever we used to write down the rate constant, have you remember? Law of mass action, Kf will be, because if A is converting to B, if it is your reaction, then rate we used to write down, rate will be equals to K into active mass or molar concentrations of the reactant raised to the power of the stoichiometric coefficient. Now here the concentration term used to come over here picture. That's why here what K equilibrium directly you will get when you will put K by Kb equals to equilibrium constant, which is nothing but a Kc, you will get it over here. Now, by this way you will get, and now they are telling Kb equals to 21,000, 25,000 into Kf, and that you will put over here. Kf by Kb equals to, instead of Kb you will find out 22,500 Kf cancel out, 1 by 2,500. That is your Kc. Now, once you get the Kc, Kp equals to Kc into R to the power delta Ng. Delta Ng equals to number of moles of gaseous product, total number of moles of gaseous product minus total number of moles of gaseous reactant. Kc you got 1 by 20,500. Then R equals to, they are telling 0.083. Temperature they are telling 1000. and delta Ng will be equals to 1 because the reaction 2 minus 1. So then if you calculate this value will give rise to 0.033. This roughly this value is to come. That's why which options will be your answer, my dear student? In the option they are directly giving, this will be your answer. These things is very easy. 1 by lambda will be equals to, you have to take two cases the ratio. 1 by lambda will be equals to, the direct formula will apply for this. 1 by lambda equals to R into Z square, 1 by N1 square minus 1 by N2 square, where Z is 1 for the hydrogen atom, and two cases you have to take the ratio and you will get your answer 1 by 4. Now look at the next slide. Here very nice example giving, my dear student. If you look at here, they are asking among the compound correct order of bond dissociation energy. Bond dissociation energy directly proportional to bond strength directly proportional to overlap. So now if you look at here, overlap is sp2 versus s, this carbon versus this hydrogen 1s. Now here overlap is sp versus 1s, here overlap is sp3 versus 1s. Here percentage of s character is 33.3, here percentage of s character 50%, percentage of s character 50%, here percentage of s character 25%. If percentage of s character is more, overlap will be more. If overlap is more, bond strength will be more. Bond strength more means bond dissociation energy will be more. That is the idea based on that question. So that means here percentage of s character is 50%, then my overlap will be more, bond strength more, bond dissociation energy will be what? More. That's why my order will be 2 greater than, this will be the highest, 2 greater than, 1 greater than 3. Then where is the option? 2 greater than, 1 greater than 3. Third options will be your answers. Now here which concept you will apply? If you look at which of the following are paramagnetic. If you look at chlorine is a weak ligand, nickel is +2 state. Weak ligand means against the Hund's rule no pairing. Obviously directly without seeing itself I understood NiCl4 there will be unpaired electrons. Hybridization, if you check it out, this NiCl4 2 minus, the hybridization there will be unpaired electron and the hybridizations will be sp3 hybridization. But NiCO4 also sp3 hybridization, be careful. 2 electron from s orbital will come to the d orbital and then they will get pair up. Here picture look at, nickel is +2 state, my dear. So overall charge here is to have 2 minus, nickel is +2 state. This will be 3d8 4s0 configuration. 3d8 means like these situations. 3d8 means 1, 2, 3, 4 and 5. 5 room will be there, d orbital. So now, and then d electron 5, 6, 7, 8. There are 2 unpaired electron is there. Now, as well as you have a vacant 4s and as well as you have a 4p, as well as if you look at you have a 4d like this, here 4d is there. Then ligand will make a coordinate covalent bond like this. So hybridization will be sp3. But NiCO4 what will happen? Nickel in 0 state. Then whatever electron 4s will be there, that will come to the d orbital. D orbital by pairing also will be there and that electron will come over here. Hybridization will be sp3. There will be no unpaired electron, strong field ligand. Cyanide, before doing itself you can do cyanide strong field ligand. Again the Hund's rule pairing will be there. And only if you look at H2 and PPH3. PPH3 also there is a strong field ligand. PPH3 there is a strong field ligand. And now the idea is PPH3 strong field ligand means before itself what I can understood. Hybridization will be sp3 exactly like a NiCO4 situation. Hybridization sp3 against the Hund's rule pairing will be there. But only if you look at very carefully, this number of unpaired electron will be present. Here also will be present water, weak field ligand with a nickel, and here also weak field ligand. So that means A and D there is a weak field ligand, unpaired electron will be there. Other cases cobalt, cyanide, NiPPH3 strong field ligand against the Hund's rule pairing will be there. Here some people thinking sir, here nickel 0 state, here 0 state, how the pairing? The idea is like this. If you have like this, you have 1, 2, 3, 4, 5. Now against the Hund's rule pairing will be there and here also you have a 2 electron. Whenever against the Hund's rule pairing will be there, these two electron will shift over here and this electron will shift and get paired up. So then that time your scenario will be like this. Picture will be like this, 1, 2, 3, and like this 10 electron is like this, and s orbital will be vacant, p orbital will be ligand, will be donated like this, hybridization will be sp3. In case of NiCO4, NiPPH3, like that situations will be there. There will be no unpaired electrons. So that's why they are asking that which of the following are paramagnetic. NiCl4 2 minus unpaired electron, NiH2O whole 6 2 plus unpaired electron. In NiH2O whole 6 hybridizations will be there what? The hybridizations will be there sp3d2 hybridization. That means s orbital, p orbital, outer d orbital will include these hybridizations. There will be no pairing against the Hund's rule. That's why your these and these will hold the unpaired electron and paramagnetic. That's why first options will be your answers. Now look at the next slide. Here these things everybody you can do like this very quickly. This pernicious ammonia, this is your Rickard, and these things, this one and this you will get it. That is no issue. Now next one is base strength of decreasing order, basicity order they are asking. What is N-methyl ethanamine? N-methyl ethanamine is this one. This is your N-ethyl methanamine. Next, ethanamine means this is your ethanamines. Next one is N-methyl aniline. Aniline means N-methyl aniline. This is your methyl, this is aniline, and this is your only aniline. Now if you look at very carefully, compared to aromatic amine, aliphatic amine are more basic in nature. So that's why this has this two is aliphatic amine, this two is aromatic amine. Due to resonance, nitrogen lone pair will be benzene, resonance with a benzene ring. So that's why now between these two aliphatic amine, both the side nitrogen has a alkyl group which is giving the plus I. Because of that, electron density over here increases. But here only ethylamine giving one direction plus I. That's why N-ethyl ethanamine has a more basicity compared to ethanamine. And you know very well, aniline will be least because their methyl group will give plus I. That's why N-methyl aniline has a more basicity than Benzene. Benzene means aniline. This Benzene means aniline pH NH2. That is the idea. So that's why which option will be the answer? First options will be your answers. Now if you look at the next questions. Next question based on correct order of the wavelength. Whenever there is a strong field ligand will be there, then your energy, strong field ligand, your delta E will be more. Delta E will be more means nu will be more, lambda will be what? Less. Weak field ligand means delta E will be less, your nu will be less, wavelength will be what? More. This is the concept. Now if you based on that, if you look at ammonia is a strong field ligand with a cobalt, cyanide is a strong field ligand, then water is a weak field ligand. Now if you look at the options, very carefully, then they are giving the copper with H2O, copper has a +2 charge. Now, whenever charge of the central metal ion is more, there also splitting will be more, interaction, metal ligand interaction will be more, splitting will be more, delta E will be more, because both cases is a water is there. But here copper +2, and this is a obviously copper +2 weak field ligand. There will be a tetrahedral complex, and these will be nothing but your octahedral complex. You know octahedral splitting will be more. So that's why delta E for the octahedral also will be more, and that's why sequence will be more, wavelength will be less. Maximum wavelength will be there for the what? C, because their delta E will be less, and then wavelength will be also what? More, because energy is inversely proportional to wavelength, directly proportional to frequency. So that's why the order will be C will be the highest wavelength, then will be there D, then will be there your A, and then last will be there your B, because cyanide is more strong field ligand than ammonia. So that's why the B will be the least. So that's why which options will be the answer? Fourth options will be your answer. Actually ammonia is a weak field ligand with other cases. Only with cobalt +3 state ammonia is a strong field ligand. So now if you look at the next slide, In this slide, if you look at very nice questions, here what they are giving? Here they are giving HBr benzoyl peroxide. That means what? It's a, even you can do the radical pathway reaction will go, and it's nothing but a anti-Markovnikov product, Kharas effect or peroxide effect. So that means radical pathway means what you will get? First, anti-Markovnikov product, you will get radical like this, here dot. Now, where the Br dot will attach? If you look at very carefully, Br dot and anti-Markovnikov product. Again, you can think properly, proper logic. If you look at generally anti-Markovnikov product means that Markovnikov used to say the negative part of the addendum will add to that carbon atom which has a least number of hydrogen. That means anti-Markovnikov means negative part of the addendum. Addendum means HBr. Br minus. Negative part of the addendum will add to that carbon atom which are holding more number of hydrogen atom. So here only more number of hydrogen atom. So that means bromine will attach over here, and your hydrogen will attach over here. Even though you can understood logically as it is going radical pathway, 3 degree radical will be more stable than the 2 degree radical. That's why bromine will add over here, not over there. So now you will get this one. After that, cyanide giving means what you will get? Cyanide giving means KCN, you know very well. From the carbon center attack, SN2 attack, and this is done. Then you will get like these pictures. Here CH3 is there. Here you are getting cyanide. Cyanide reduction. This is a sodium and C2H5OH. Electronation, protonation reduction. Then immediately this part will be converted to like this. Your CH3 and CH2 NH2. That's why which options will be your answer for this question? Methyl group will be there. Here cyanide ultimately converted to CH2 NH2. That will be your, this will be your answer. Now come to this question. They are telling which of the following compound does not decolorize. If you look at bromine, here bromine water will be positive test, unsaturation is there. Aniline will react with a bromine, exactly they will form 2,4,6 tribromo aniline. This compound and color will decay. Phenol also will form exactly same manner, 2,4,6 tribromo phenol, and bromine water color will be decolorizes. But here degree of unsaturation present due to cyclic structure, but there is no unsaturation or there is no group which that bromine water can react. That's why they are asking which of the following compound does not decolorize the bromine water. This will be your answers. Now look at the next slide. In this slide, they are directly matching up chloroform and aniline. It's simple distillations you can separate out. Glycerol, everybody knows, reduced pressure. Distillation under reduced pressure. And crude oil, they have a very close melting point, means fractional distillations. You can easily do it by fractional distillations. How you can do? You look at these things, glycerol and this reduced pressure. What I told, glycerol and these things, your reduced pressures. This is your reduced pressure. And these things by simple distillation. And aniline water is a steam distillation. Crude oil and this one is a fractional distillations. That means B will go with a 3, A will go with a, here itself I am writing, A will go with a, if you look at, A will go with a 4 and B will go with a, B will crude oil fractional distillations, very near melting point. B will go with a 3, glycerol. C will go with a 1, distillation under reduced pressure. Hello student, due to sudden power up, the last video cut up, so I want to complete that our discussions for NEET 2025 chemistry. Welcome back to the channels again. So now if you look at here the questions they are giving, which of the following compound can exist as a cis and trans isomers? If you look at over here, they are giving 1,1-dimethyl cyclopropane. So cyclopropane structure is this 1,1-dimethyl. The condition of a cyclic structure to be geometrical isomers, I need 2 disubstituted sp3 carbon and the group attached individually should be different. Now here 2 group or 2 atom is there, methyl, here hydrogen, and here also hydrogen, hydrogen. They should be individually different, and that type of two carbons should present. Then only they can show geometrical isomers or cis-trans isomers. Now 1, 2 dimethyl cyclohexane, if you look at 1, 2 dimethyl cyclohexane, that means these things. So now here methyl group is there, hydrogen is there, methyl group is there, hydrogen is there, but all place hydrogen, hydrogen. That means that type of two carbon is there, sp3 disubstituted, and individually group are different. Now there are two possibility, like one will be arrangement will be like this, 2 methyl are up or 2 methyl are below. Next possibility, 1 methyl up and 1 methyl below. Now you look at, if you look at 2 methyl up or 2 methyl below is the same situation. That means both cases there will be POS. It's like a meso type. Whatever meso, 2 up meso or 2 below meso. Meso is meso considered as a one type of arrangement, and another possibility 1 up, 1 below. So that's why there are how many geometrical isomers is as possible? There are two geometrical isomers possible. One is, this is called cis, and this is nothing but a trans situation. Now pent one in means like this, C double bond C, and pent one in means like this situations you have like this. That means here hydrogen, hydrogen will be what? Similar. Here carbon and this is different. No geometrical isomer. 2 methyl hex 2 in, 2 methyl hex 2 in, hex 2 in means like this situation, and 2 position methyl means here also methyl. These two will be same. There is a no question of a geometrical isomer for this one. Then your answer will be second option, 1, 2 dimethyl cyclohexane. Now here if you look at these questions, they are giving certain electronic configuration which are main group means S and P block they want to know. Now if you look at very carefully these electron configurations, neon code 3s1, this is a S block element. Now if you look at 3d3 4s2, D block element. Now D10, this one, this is a P block element, because P block element configuration, general configuration NS2NP 1 to 6, S block element NS 1 to 2, and now this is nothing but your thorium, this is nothing but your actinide or A block element. So now the main group means P block and in S block, which is nothing but A and C. Where is A and C options? If you look at A and C is A, C, and they are telling you nothing but a thorium. That means thorium is there. And now if you look at this one, these things also S block element, because D10 after that 4s1. D block element, D10 means, if you look at D10 configuration means argon code D10 configuration. If you look at, they are asking which of the following electron belong to main group element. Then if you look at the situation, now A and this is not S block, this is the D block element, D10 4s1. D10 4s1 means it's like a copper, this is for copper. Then this is a D block element configuration. So this is your D block element, and this is S block, this is P block. A and C only is main block element. Where is the option? Fourth option is there, A and C. So that's why this A is S block element, B is D block element, C is P block element, D is D block, copper configuration, E is thorium, A block element. So that's why S and P means A and C will be your answers. Now the last questions of discussions, very nice questions. This one organic question, and maximum student made mistake. I hope these things, if you don't have very good depth of the concept, you can't solve these questions. Now the question is CS3 MgBr, they are giving excess over here. Grignard reagent, organometallic compound. Then Grignard reagent means what will be the situation? CS3 MgBr. Then this will attack first over here, open up, because the Grignard reagent, there are 4 category of reaction is there. One is, first is acid base reaction. If acidic hydrogen is there, the negative part of the organometallic will absorb that one. Next, nucleophilic addition. If the electrophilic carbon or electrophilic site is there, then nucleophilic additions will be there. Next, SN2TH, like a acid derivative, RCOCl, RCOOR with Ester. So like that, there will be SN2TH, tetrahedral pathway substitutions. That means attack to the carbonyl carbon, bounce back of electron from O minus, and departure of a leaving group Cl or OR minus, like that. Next reaction Grignard will undergo. You know, if you have a cyanide group, Grignard will undergo nucleophilic additions reactions, as well as cyanide reaction with the Grignard, nucleophilic additions and formation of aldehyde and ketones. But by this question itself, everybody will understood here Grignard will attack and cyanide hydrolysis means carboxylic acid. It's wrong. Why? Because you look at the entire mechanism of the questions. In entire mechanism of the questions, what is going to happen? This is your structures they given. This is your structures they are giving. Cyanide means like this situation, and Grignard is in excess, then CH3 MgBr, one attack over here, open up. Next, another molecule of Grignard, another electrophilic side is there in cyanide, attack and open up. Preparation of aldehyde and ketone, NCERT book also there, RCN, HCN, Grignard reagent, aldehyde and ketone preparations. And now immediately if you look at, you will get like this situations. Here you will get O minus MgBr, and now here your CH3, and then here CH2, and here also your Grignard will attack, and then here double bond N minus MgBr. Now whenever you will go for hydrolysis, first what will happen? This part will take the positive part of water and MgBr will take the OH, same way. Positive part of the water taking means like this situation. Then you will get like this compound. You will get here OH and here your CH3, CH2, and here your CH3, double bond NH. It's like imine will undergo hydrolysis again. Water molecule is there in the medium, attack, open up. That means here we will get like this situation. COH, CH3, CH2, here you have a CH3, and now here OH, proton loss from over here, and then here proton gain like this situation. Now ammonia will go out, H from here, H plus from here, NH2 minus over here. Ultimately your product you are getting, this compound will be your product. You look at here OH, here CH3, and then here CH2, here CH3 and double bond O. So you will get this compound will be your product. Not that here people will think CH3OH and cyanide means COOH. You will get this will be your product. That's why you need to know in detail of this reaction. Then only you will be able to attend this type of questions. I hope you got the clarity about the what I discussed regarding the NEET 2025 papers. And to get more and more clarity, please come and join and subscribe my channel. Then only depth of the concept like this type of question paper you can handle without any confusions, without any doubt, with a full clarity you will go through your exam. Thank you very much. Thank you for upcoming aspirant, this year aspirant, all of you. Thank you very much. Thank you all.